geometric inequality question from imo1991Q1. Given that AA prime, BB prime, CC prime are all angle bisectors, where A prime, B prime, C prime are on the side of the triangle ABC, meaning that the angle A prime AB is equal to the angle A prime AC, and angle B prime BA equals to the angle B prime BC. And these three angle bisectors concurrent at the point I. So we have to prove this inequality. Now note that the upper bound can be proved using AMGM inequality, and note that we are unable to achieve the value of the lower bound. That's why it's strictly less than. The upper bound, we have to use angle bisector theorem, which stated that if this is the triangle ABC, then if this is C, we call this C and this is B. AD is angle bisector, where BD equals to P and DC equals to Q. The angle bisector theorem says that if so, we have C over P equals to B over Q. Okay, or sometimes we write as C over B equals to C over B equals to P over Q. They are equivalent. We are going to use angle bisector theorem to the triangle CAA prime and to the triangle ABC. We'll look at it now. So before we use angle bisector theorem, we need to let AB, the length AB equals to C, the length AC equals to B, the length BC equals to A. And we also let CA prime as P and A prime B as Q. So now we are ready to use angle bisector theorem. We focus at the triangle AA prime C. So AA prime C, since this is angle bisector, then we know that AI over IA prime will be equal to B over Q. So AI over IA prime will be equal to B over P. And if we look at the triangle ABC, then we have B over P equals to C over Q. B over P equals to C over Q. B over P equals to C over Q. And now we can combine them, and we have AI over IA prime equals to B over P, but B over P equals to C over Q. And if this is so, we can combine B plus C over P plus Q. And P plus Q is actually equal to A. So this is B plus C over A. So if this is B plus C to A, if this is B plus C to A, then this will be B plus C to A plus B plus C. AI over AA prime equals to B plus C over A plus B plus C. So this means that AI over AA prime equals to B plus C over A plus B plus C. We are able to write the first fraction in terms of the side of the triangle that is in A, B, and C. By using the similar argument, we also have BI over BB prime. We will have C plus A over A plus B plus C. And likewise, CI/CC prime equals to A plus B over A plus B plus C. So this is crucial, and we need this to show the upper bound, and we also need this to show the lower bound. And now we are going to use AMGM inequality. We will let this expression equals to J. So we will multiply everything, A plus B, B plus C, C plus A over A plus B plus C to the power of 3. By using AMGM inequality on these three terms, that is A plus B plus B plus C plus C plus A over 3. Using AMGM inequality, the sum of these three terms over 3 will be greater than equals to the product of these three terms raised to the power 1 over 3. That is A plus B, B plus C, and C plus A. So with this, we know that this one will be less than or equals to the power 3 of whatever we have here. Okay, and don't forget the A plus B plus C power 3 here. Okay, so this will give me over 3, and this is actually a double of A, B, and C. So with this, we know that A plus B plus C to the power 3 will cancel off, and we left with 2 over 3 power 3. 2 over 3 power 3 is actually equal to 8 over 27. And we show that this is the upper bound. And we always want to ask when the equality holds. Equality holds if and only if the first term equals to second and equals to the last term. From these two, we know that A equals to C, and from these two, we know that A equals to B. Implies that A equals to B equals to C, which means that J is equal to 8 over 27 if and only if ABC is an equilateral triangle. And the I here, instead of in center, it can be also as a centroid. Okay, and we know that the centroid, this is 2 to 3. So we have shown the upper bound. Okay, welcome back. So this is what we have for the first half, and for the second half we need another diagram, and this diagram is as follows. In this case, we no longer need the A prime, B prime, and C prime. We need A double prime, B double prime, C double prime, because I is the in-center of the triangle ABC, which means that we can form an inscribed triangle here that the circle touch the side at A double prime, B double prime, and C double prime. Okay. Now we let this length be x, and since this is the tangent, if AB double prime equals to x, then AC double prime will equal to x. Likewise, if BB double prime equals to y, then BA double prime equals to y. And lastly, CA double prime equals to z, if and only if C double prime equals to z. From this, we will know that x plus y plus z is equals to half of A plus B plus C. So AI over AA prime will equal to B. B is equal to this. So it's x plus z plus C. C is here, x plus y, over, and A plus B plus C will be equal to double of x plus y plus z. And this is over 2. We can take the 2 out. So it's x plus y plus z plus x. So we can separate them, and this is 1, and this is x over x plus y plus z. So using the similar argument, we will have BI over BB prime will equal to half 1 plus y over x plus y plus z. CI over CC prime equals to half 1 plus z over x plus y plus z. Now we will let R equals to x over x plus y plus z, RST, y over x plus y plus z, and t equals to z over x plus y plus z. So what we have here is j will equals to half, so 1 over 8. This is 1 plus R, 1 plus S, 1 plus T. So this will equal to 1 over 8, 1 plus R plus S plus T, RS, ST, TR, and RST. Now note that the sum here is equal to 1. Okay, r plus s plus t is equal to 1. So this is 1. Everything here is positive. So this is greater than 1 over 8, 1 plus 1. And this is 1 over 4. Show that this is greater than 1 over 4. And we can also see that 1 over 4 is the best lower bound. The value of j can be very close to 1 over 4 if we let c to be very close to 0 and we let a equals to b. The first fraction will get very close to half, second fraction also very close to half, and the last fraction is very close to 1. So the product will be very close to 1 over 4. And that's why we claim that this is the best lower bound. So with this, we end our lesson today and see you again. Bye-bye.